Thermometers. Do you use a digital or an analog for when you're frothing your milk? And how do you calibrate them? Stay tuned, I'll tell you everything you need to know. Welcome back to our masterclass series on milk frothing. One really important part that we feel that we want to nail into a little bit is the good old thermometer. Obviously we look at coffee machines and milk jugs, but how you get the right temperature milk is so crucial. So we have digital thermometers and we have analog thermometers. Now, why would we choose one or the other? Well, typically in the industry we always use the analogs. They're cheap, they're $5 to $10 each. And a digital is going to set you back maybe 20 up to, over $100, depending on which type you're after. Now, why would we pick one or the other? Well, the digital is amazing for giving you accuracy. There's no doubt that is the product that is going to give you the exact temperature if you want to know what temperature your milk's at. But how to use it as a tool when you're frothing milk, it is really quite tricky, because the gaps that it will make when it's actually reading can be very large steps. It can go from 30 to 40 to 70 really quickly. Now, what we want to do is slowly see the process of that temperature from 4 degrees cold milk up to 60. And that's where we'd be stopping, because we want to stop 5 degrees before our desired temperature. And what these thermometers do, the analogs, is it allows us to see that gradual growth. It's a really great guide for us to see what's happening with milk. If you use a digital like this, it can sit in the jug and very easily face the wrong way. So that's another little thing which is a bit tricky about them. So when you pop in your analog, you can actually sit it straight on. That face is showing right to you, and you can see clearly what's happening while you're frothing. Now, we've got a couple of different ones here. We've got one that's very well used. It's a short stem. It's got some cracks in it, and that would need to be adjusted for sure. But we're going to do a test on it. And we've got a brand new long stem out of the box, and obviously we've got our digital. So what we're going to do is we're going to calibrate these at a cold temperature, and we're going to calibrate them at a hot temperature. So that allows us to see that we might be great around that 3 to 4 degrees with cold iced water, but when it actually starts to work, how is that actually calibrating as it's actually going up to be that hotter temperatures? So I've got my ice water, and we're going to test what the accuracy is across these 3 different thermometers. Okay, so here we go. So we've got our digital, which is coming down to, down that 4 degrees, 4.2 at the moment. You can see that these ones are making their way down. This new one is almost at 5 degrees, and that gradual temperature is really handy for us to be able to see what's actually happening and respond while we're frothing milk. And that's why we do love the analogs. Now this one here, the old battered one that's come straight out of a cafe, is at 20 degrees. So it has been knocked about, it definitely needs to be calibrated. But the new one out of the box is very close. I mean, that's sitting just below the 5 degrees, and here on the digital it's saying it's 4.3. So new out of the box, that's perfect, ready to go. But we do need to calibrate the good old trusty one that's been around for a while. And how do you do that? Well, you're going to need yourself a little shifter or a spanner of some sort, and on the back there's a little nut here. So what you need to do is you just want to lock on that spanner, and we're going to calibrate this. Now we're going to try and move this gauge lower towards the 0, because we know it's at a higher temperature. And it might take a few goes to get this, but I'm going to try and just tweak that a little bit. Oh, might just try it upside down here, guys, hang on. Oh, okay, so I got that to move a little bit. Let's just quickly retest that. Okay, firstly we can see it's already coming below 20 degrees, so I've gone in the right direction. And the current temperature is at 4, It's coming down to halfway now, so that's at below 10 degrees now, so we're getting pretty close. It could do with just a fraction more on that one. So let me just try and tighten that one more time. These are quite small and quite fiddly. There you go, I got that one then. Okay, so you can see now we're down below that 5 degrees, which is pretty much spot on. So that's great. So that's how you calibrate at cold. Now we need to look and see how they're actually reacting with the hot water. Let me just get some hot water. Okay, so now I've got the hot water. Let's see what's happening. We'll pop in our digital there first. We can slot our analog on there and the one we've just calibrated. Alrighty, so we can see them reacting at different speeds. This one's come straight up to our 89, 90. This has come out of the hot tap from a coffee machine, so it's not set to be boiling. And you can see that the new thermometer is pretty much on that 90, just over, maybe 91. So we're very close here in the hot side of things. And on the small one we've had in the cafe for a while there, you can see it's probably just a little bit, actually that's pretty spot on now, isn't it? So it's very close. So we've calibrated it, but before that was not going to give us an accurate reading. Now just to show you why we love the analog over the digital, I'll show you now. We're going to go from hot to cold. Now you can see we're at 90 degrees as we take that out and pop it in the cold. Look how quickly this reacts. It just jumps like nearly 40 degrees in a second. So it's just too quick. The increments that it's going to change as it's going up or down is actually going to be hard for us to analyze while we're frothing milk. So I'll show you again just as we go back to hot. Let's quickly show you. We're down at 6 degrees and we go back into hot. Boom, it just jumps straight up really quick in increments of 20 because it is such a fast processor. So for us, with milk, we want to have a nice, slow, gradual indicator that allows us to know what's happening with our milk. And we want to be able to stop 5 degrees before the temperature that we're after. So if you can see that needle going up and it's coming up to 60, you kind of can think in your head, oh, okay, that's 3 seconds to go 5 degrees. I know I've got 3 seconds at 60 before I need to turn it off to maybe 65 degrees. And I use that technique for people so that they can calibrate with their hands. Because that's one thing that you'll see a lot of cafes doing. They won't always have a thermometer in there. And what you're doing is basically putting your hand under the jug. And I like to use this part of the palm, not your fingers, because your fingers are used to heat. So as you pop it underneath, if you can't hold it there for more than a second, you need to work out what temperature that is on your thermometer. And then count how many seconds it takes to reach your desired temperature. Now, in training, I normally say to people, once you can't hold it, you wait 5 seconds, 1, 2, 3, 4, 5, and then you turn the steamer off. And then you go back and check the temperature. Now, if you're finding that you're going above 65 degrees, you need to be only counting to 4. If you think that your hand is a bit softer and you're finding it's a bit hot, you need to increase your time or your number of counts, maybe to 6 or 7 to hit 65. And that's a great tip. So hopefully that gets you calibrating your hand. If you're pumping out heaps of coffee every day, that's the best way to make sure that you're serving consistent milk. If you've loved this video, make sure you like it. And if you've got a question, shoot us a comment, hit the little bell icon, and then you'll be notified when we send out our latest video on the milk series as well. There is more to come. Thanks for watching, guys. Have a great day.